In today's Private Pilot Ground School Lesson 1.6 on the 7.6 Ground School Chick channel, we're going to discuss ground effect and wingtip vortices. You will need to know this information for your check ride and your FAA written exam. Let's dive in by talking about wingtip vortices. In our previous video, we talked about how airflow over the surfaces of the wing create a low pressure area on top of the wing and a high pressure area on the bottom. Wingtip vortices are swirling air currents that form on the tips of an aircraft's wings. They are created due to the pressure difference between the upper and lower surfaces of the wings, because high pressure seeks and moves towards low pressure. We will also notice this when we start talking about weather. When the aircraft generates lift, high pressure air beneath the wing flows towards the lower pressure area above the wing, resulting in the formation of vortices. These vortices create a swirling motion of air behind the aircraft called wake turbulence, which can be a hazard to other aircraft flying in the vicinity, much like a boat leaves turbulent wake in the water, which affects boats in its vicinity. This is not surprising if we keep in mind that water and air are both fluids. It is important for student pilots to be aware of wingtip vortices and maintain appropriate separation with following or crossing the flight path, and maintain appropriate separation when following or crossing the flight path of larger aircraft to avoid encountering the turbulence caused by these vortices. The bigger your wingtip vortices are, the more induced drag you have. The size and strength of these vortices depend on the angle of attack of an aircraft's wing. So if you have a higher angle of attack, you'll have bigger and stronger vortices, which means more induced drag. Induced drag is related to our airspeed. When we're at lower airspeeds, we need a higher angle of attack to maintain level flight and to create enough lift to equal the weight in our airplane. If we increase our airspeed, we don't need as large of an angle of attack to maintain level flight. This gives us less induced drag. So, although it can be hazardous to fly through another airplane's wingtip vortices or wake turbulence, it can be especially hazardous to get caught behind a larger, heavy aircraft. Takeoffs and landings can be particularly dangerous if you encounter wake turbulence. Flying through these wingtip vortices can cause your airplane to flip over, or it can cause you to lose control of your airplane. If your airplane gets flipped over when you're at a low altitude above the ground, you may not have enough time to safely recover. It's important to know that the airplanes that create the biggest hazard are ones that are heavy, clean, or flaps up, and slow. Heavy airplanes need to maintain a higher angle of attack in order to produce enough lift to fly, and a higher angle of attack causes bigger and stronger vortices. These vortices sink at a rate of several hundred feet per minute and move outward away from the path. How do we avoid wake turbulence? The first approach is to avoid flying through another aircraft's flight path. Since the vortices sink, flying above that airplane's path will keep you out of wake turbulence. Wake turbulence starts to be created after rotation, and it stops being created upon landing. When the wings are no longer creating lift, the wake stops being created. With this in mind, the best way for us to avoid an airplane's wake on takeoff is to leave the ground before we get to that airplane's rotation point. When landing, we want to touch down farther down the runway than where the previous airplane touched down. What if we don't know exactly where the airplane in front of us took off or landed? In that case, it is recommended that we wait 3 minutes for the vortices to dissipate to give us a good safety margin. When there's very light or no wind, these vortices dissipate by moving away from each other laterally. Something to be really aware of is that a crosswind of 1 to 5 knots could cause the upwind vortices to stay on the runway a bit longer. When this is the case, it is recommended to wait the full 3 minutes and be prepared to go around if necessary. The reason we've been talking about wingtip vortices in this lesson on ground effect is because ground effect is caused in part by the airflow around the wing being disrupted by the ground when we are within one wingspan of the surface. This is why, when you first start practicing landings, you will notice that the airplane floats down the runway a bit. When we get in close proximity to the surface, some of these airflow patterns get disrupted. One way that the ground disrupts the airflow is that it reduces the size of the wingtip vortices, and with that, we get less induced drag and more lift. We also get reduced downwash, which means less induced drag. With so much less drag, that means that less thrust is required. And because we also have increased lift, if you're above the recommended landing speed, you could float quite a bit. It can cause issues if we wanted to land on a short runway or in some runway and weather conditions. This is why we need to consider ground effect during landing and takeoff as well. If you don't use the recommended techniques and procedures, your aircraft could become airborne before the recommended takeoff speed. If that happens, and you continue to climb until you are no longer in ground effect, you will immediately need a higher angle of attack to maintain your lift. This will also increase your induced drag, which will cause your airspeed to be lower and reduce your stability, which can make it tough to control your airplane. And once the airflow and drag go back to normal without the interference of the ground with the airflow, which had been giving you that added lift, you could find yourself with insufficient airspeed to maintain flight, and that could cause a stall spin situation. It's important to never leave ground effect until reaching a good climb-out speed. Additionally, it's good to know that ground effect affects low-wing aircraft more than it affects high-wing aircraft because when the wings are closer to the ground, they are more susceptible to ground effect. I hope today's lesson was helpful. If it was, please like, subscribe, and hit the notification bell so you don't miss out on any future private pilot ground school lessons. And if you're interested in doing your private pilot ground school online directly with me and have me sign you off to take your FAA private pilot written exam, please reach out at chickswhoflyofficial@gmail.com.